University, and my handle on Twitter is @SecurityGuy. Okay, so views after free vulnerabilities. They are a class of vulnerabilities that exploit memory locations that have been deallocated. Okay. So OWASP states that they're a class of vulnerability that has very high severity. The likelihood of exploiting them is high. They're generally induced in two ways. Confusion regarding which segments of code handles free memory, and error conditions that free memory but do not dereference the pointer to that memory. Why are they important? Use after free vulnerabilities have nearly the same impact buffer overflows. The ability to compromise data stored in memory, the capacity to crash the program that's running, the possibility to execute arbitrary code. If the programmer learns about any vulnerabilities, generally they're going to only learn about buffer overflows until they become a much more experienced programmer. It is a current attack vector. We have NS1263, which was a vulnerability in Microsoft Internet Explorer, which was a use after free vulnerability. Metasploit has a great summary of how the details worked, as well as Alienable and Vulnhunt. They had some really great write-ups that get very technical. Again, this is an introduction, so I'm not going that hard. I am going to do a demo of that vulnerability. So, slow it up. Vulnerability. So I'm just setting everything to backtrack box. That's what it is. You can use payloads if it's a payload. Just as easy as someone visiting the page. We don't see anything. accept a redirect. Sometimes it crashes and it reloads it. That's why I prepped the video, so I can go to the end of it. Right about the same process and hit my rates to show. But this is a serious vulnerability. It gave the attacker privileges equivalent to that Internet Explorer was running on. So I created a bit of code to help people who haven't been introduced to this kind of vulnerability. A lot of programmers are starting in Java and hopefully with pointers. This is just a bit of introductory code to help them get acquainted with the ideas behind the use after free vulnerability. So it just it's going to create some buffers that are public that they should be able to see, some buffers that are private. It's going to create some buffers that are private that they shouldn't be able to see. It's going to display them before it frees memory. It's going to free the memory from one of the buffers. It's then going to allocate 2 private buffers. Those private buffers are not going to be not supposed to be seen by the user. Then it's going to display the pointers and execute a simple use after free vulnerability so that we can see the concepts behind it. And showing the pointers will show why a use after free vulnerability works. In the end, it will print all buffers public and private so that we can see the consequences of the vulnerability. Yes?
So what is the difference between a public and a private buffer?
I can't hear you.
What is the difference between a public and a private buffer?
The public buffer is simply one that we give the user access to with the command line arguments, and the private buffer is one that they should not have access to. Okay. So, can everyone read this?
No.
Okay. Let's see if I can make it any bigger.
Maybe can you turn off the
Can you
lights?
turn off the lights?
Oh, okay. Yeah.
There.
Is that better?
Drag that window a little further. Right. It's not going off the screen.
Okay. So this is taking in the arguments users can write, users can read, and mine now. So we're going to see that public buffers with our arguments we can read and write to. Okay. Then we are creating our private buffers after we free public buffer 2. Because we did not null the pointer for public buffer 2, we can see that public buffer 2 is pointing to the same memory location here as private buffer 1. So they were allocated the same space because we freed it and we did not null that pointer. Publicly, we still have access to what is now supposed to be private data. So we display public buffer 2 again, and we can see this private data that was not supposed to be displayed. We write to that buffer, and we can now write over this data that was supposed to be private. I run it again, this time with using a larger buffer for my third argument, and I can actually switch which private buffer I'm writing over. So I'm going to dissect a bit what's happening. So malloc is the system call used to ask the operating system for memory for your program and your variables. So here we can see that we're calling the system call malloc, and that we are getting a result pointer, result memory location EAX, and we are moving that into these local variables, local 1 and local 2. These are public buffer 1 and public buffer 2. Okay, that was just, the line above that is just one sample. There would have been a second line that said public buffer 2. The next thing that code used was string copy. Okay, that's going to take one of our arguments from the command line and put it into our public buffer with a third argument of the size of that buffer, so we're not going to be using buffer overflows. So then we're going to get to the parts that are a bit more interesting to this vulnerability. We have a free followed by a memory allocation. Okay, and we're going to take a closer look at this. Right, so when we call the memory allocation, we can see that it returns C1148 for the memory location, and then when we call the next one, it's going to return a different value. But when we go to access local 3 is still storing C1148, which local 3 is public buffer, but C1148 is now supposed to be private memory. So again, this is a simple example just to introduce people to the concepts behind a use after free vulnerability so that people can start diving in and learning more about them. This was just the case where a program isn't as sure where it's supposed to be dereferencing memory and who's supposed to be taking care of that. Another common example is in your error handling. You create a buffer, you error out, and you didn't clear, you didn't dereference your pointer, but while you did clear your buffer, or deallocate your buffer.
So would this be a case of if you were doing static code analysis, you could look for some of these? And
yes. It's a little bit harder with some of the error handling, but if you create robust methods where whenever you are deallocating your memory, you make sure that you're handling the pointer to that memory as well, you can avoid a lot of the simple cases of a use after free vulnerability. Yes?
Are there any debugging or programming tools like Valgrind that would help you spot these kinds of things happening in your code?
None that I could find that I could afford. There may be some, but they're not at a level where a student can play around with them. Any other questions? This one's supposed to be a fireside, so I tried to keep the the presentation part of this quick so that I can facilitate more discussion. Yes?
I just want to clarify that I'm understanding this correctly. This class of vulnerability is only going to affect C and C++.
C++, assembly, but a lot of things are written in this. So anything that has pointers and is allocating memory and deallocating memory, if it's not handling its deallocation correctly, you can end up in a situation where you can still access memory without it being allocated. You can access memory, I guess, out of context would be a good way of putting it. I mean, we've got about another 15 minutes of this. It's supposed to be discussion. So, does anyone have any suggestions as to maybe how we can better encourage programming students to learn about different vulnerabilities and explore themselves, how to create vulnerabilities for themselves and then learn how to avoid them in their own code writing?
Are there any, like I know OWASP has a lot of, like WebGo things, so and it makes it easy for a developer to learn how to write secure code, but from a web app perspective, I don't know. I remember seeing something on Twitter like within the past day about there being some, it's the same thing, but it's for, so that people can create something and then exploit themselves. And it seemed like it was for more developer focused, but I don't know if anyone else has seen that. But there may be something like that available that you can either bring developers through, or you could, have it be self-paced.
Thank you. Yes?
Yeah, I mean, I've seen academic programs where the professors have had difficulty just getting students to deal with memory leaks. Because I think this is one of these vulnerabilities that is generally invisible to the developer because the program can still meet functional spec and contain these it's like kind of like a strict format vulnerability. Like most of the time, you're never even going to spot it. So I think the ability to get programmers to be aware of it in the current context is going to be hard. I think without giving like libraries or other sort of simple developer tools that will handle this kind of stuff. I mean, honestly, this is sort of the reason why programming languages like Java showed up, was so that you didn't have to handle this kind of memory allocation, deallocation, and the kind of errors that come along with it. So I think it's going to be, I would guess it's going to be an intractable problem for new programmers to get them to be aware of the vulnerability to go with.
Yes.
So what happens if you always set it to null? If you always set the pointer to null
A little bit louder, please.
We
What?
can only set the pointer to null afterwards.
After you call free.
If you null the pointer after you call free, then that pointer can no longer access that location that you've now assigned to something else.
So that will go away, right? This problem will go away then, right?
That's the problem you're referencing.
In the first case, there's still difficulties with in error handling, which is how, along with another vulnerability, the Internet Explorer vulnerability came about. Again, there is a great summary Metasploit. It's a great summary about how a complex issue can arise from a couple smaller issues. And it's actually only a few lines, but they do a very good job of explaining it. Yes?
I pretty much understand what's going on here, but can you maybe explain in terms of the stack, what's exactly happening when you call, just use one private buffer and one public buffer, and just what happens when you call free, and then if you were to null it, what happens?
Okay, so there's two components, okay? We are asking the operating system to allocate us memory, and it returns us a memory address, which we then store in a pointer. Now, we can tell the operating system that with free that we don't need that memory anymore. However, if we don't tell the pointer not to point there anymore, that's when this vulnerability can happen, because you can access, that can be in a different scope and now accessing memory that should be out of its reach at that time. Does that help?
Yeah, that's fine.
Okay.
Do you feel that any time that you free a buffer, if you just create a pointer, if you then null it, so if you're just always look for any time you free it that you write null, would that just, I mean, I know that you mentioned there, would that solve all cases of like case A?
It would solve the majority of them. There are cases where you're already, where what you're doing is you're going to point the pointer at a different piece of memory instead of just nulling it out. But the main point is that you change where it's pointing to somewhere that you're expecting it to. As well, all of the slides and the code sample are going to be in the Creative Commons on my website. So absolutely share this with people who are interested. So.